Hey everyone, welcome to the channel. My name's Nader. We're going to talk about closures in this video. I'm super excited for this video because I've been waiting to get to closures for quite a while. I feel like I say this about every single topic that I talk about, but I really do love closures, very similar to recursion. This is quite a complex topic though. I've purposely left it towards the end of this JavaScript series because in order to really appreciate and understand it, there are a bunch of previous concepts we need to understand, which we'll go through in this video together. JavaScript makes closures really fun and easy to use. But overall, it's a really powerful feature if the language supports closure like JavaScript does. It really helps you think quite differently about kind of programming in general and the way a lot of things might work behind the scenes. And it gives you a better appreciation for all the things that are being managed behind the scenes by the actual language itself. So I definitely encourage you to maybe watch this a couple of times because it probably will take a bit to really sink in. And then I always end up kind of coming back to this topic. And every time I do, even myself, having done this many times, I always seem to be able to discover new ways and techniques using closures in different code bases. And it really is a fantastic tool that we're going to be using all over the place and actually comes out more often than you think. Let's just get right to closures. All right, so I just want to kind of preface this video with what a closure even is. All right, so really to understand closure, we need to kind of combine three really central concepts. All right, so those three concepts are scope, which we're going to look at in this video quite a bit. This concept of state, which is a bit of a nuanced topic, but effectively you can think of us having already used state quite a bit throughout our journey so far with JavaScript. State just merely means storing some information somewhere in order to retrieve later, right? So we remember the state of something throughout our program, right? And then there's this concept of functions, which we've looked at quite extensively up until now. So closures are really meant to kind of bring these three concepts together, as well as a couple other smaller concepts, into something really powerful and eventually, hopefully, quite intuitive as well. Now, this word is a bit strange. So what does this really mean? I feel like it took me quite a while to actually think about like, oh, why is it called closure? So I'll just put this definition out and hopefully by the end of this video, it makes a little bit more sense. So closure, by definition, is an idea that means closing over the state of a function. Now that seems like total gibberish and maybe even like I made it up, but as we go through this video, I'd like you to think about that definition as we look at this concept deeper. Okay, so to start, let's take a look at this code that I have here together. I'm going to look at the left-hand side first, and then we'll look at the right-hand side to compare. So over here, we have a variable called prices, and it's pointing at this array of numbers. All right. Then we have a function called log prices, and it's simply going to log prices, the variable prices that we just talked about up here. Okay. And then we're going to call the log prices function. And what we're going to see is that we're going to see the array here, which is the prices array, being logged out, right? So if you think about just this code, hopefully that kind of makes sense, right? There's nothing kind of crazy happening over here. What's also interesting though is obviously we can log out prices, right? So if we have prices up here and then we ask to log it out down here, of course, we're also going to get it logged out. So what's interesting about this code, I guess interesting, is that we have a console log prices here inside a function, right? And we also have a console log prices here outside the function, right? So I'd like you to kind of take that just a little bit and just think about it, right? We have something inside a function and it's like talking about prices, right? And we have something outside the function that's talking about prices. Okay, so let's take a look at the code here on the right, right? So over here, we have a function, again, called log prices. Okay, so notice we haven't defined prices up here yet. Okay, so this is the main difference right here with this function so far. However, inside the actual function, log prices, we're going to declare our prices array. Okay, so prices is going to exist here, and then we're going to log prices out, right? Again, nothing too rocket sciencey over here. Hopefully that kind of makes sense. We've seen code like this many times, if we call this function, we would expect to see exactly this, right? We expect to see the prices being printed out because that's what the function is meant to do. But what's interesting here, right, and this is where things start to get a little bit strange, is if we try to log prices here with this code on the right-hand side, right, we actually get a reference error, right? Prices is not defined. Okay, so I'd like you to think about this. Why might this be? All right, I'd like to pull up the code here really quick in VS Code, and we're going to code this out together. And we're going to really see kind of what these reference errors are and what they actually mean for us, so that when we actually see these pop up, it makes a bit more sense and we can hunt them down much more efficiently, whether it has to do with closures or not. So I'm going to pull up VS Code here. I'm going to create a new file. I'll just call this intro.js. And inside here, I'm just going to make my little screen a bit bigger here, just so we can see while I don't have too much code on the screen. I'll just do this. I'll say const prices. This is going to be an array. I'm not going to get too fancy with the numbers here. I'll just go 10, 20, 10, 15, 20, 25. Okay, it doesn't really matter what we have in here. Then I'm going to say const log prices, just like we had in the example, right? And this is going to take no arguments, right? So the parameter list is empty. And we're simply going to console.log out the prices, right? And this is asking for the prices array, right? Then I'm going to call my function log prices, and hopefully all is fine and dandy. So let's run this. Let's see what happens. So I'd like you to think, what are we going to get when we run this code? All right, so I'm going to run node, and it's going to be intro.js, and there we go, right? Now, nothing too fancy, right? Just the array of prices. So what's happening here, right? We're declaring this variable, we have a function, and then it's logging out the variable, and we just declared that variable, so of course it's going to log it out, and we call the function to make it actually do the thing, right? Now, I know you're probably thinking, okay, Nader, like I thought this was a complicated topic. Like, why are we doing this all over again? Like, I kind of get it. Okay, like let's move on, right? But like, just bear with me while we go through this, because I promise you things are going to get quite gnarly pretty quickly. So make sure you're understanding each of these stages as we go really, really well. So now I want to do this next step, right? I want to do console.log prices down here. So the question I have is this going to actually give us the prices? All right, so I'm going to run this one more time. And we do, right? Because if you think about this, technically, if I get rid of all this code, like comment out this code, and all we have is these two lines, right? That makes sense. This is like one of the most basic possible JavaScript programs that we can make, where we have an array and we log it out. So of course that's going to work. And in this case, this seems to work too, right? Because prices is defined over here, and we can actually log it out. So that's great. Now, this is where things kind of get strange, right? So make sure you understand this example before moving on. I'm going to take this line 1, where I declare prices, and all I'm going to do is move it here inside of this log prices function. Okay, I'm not going to change anything else or add or remove code. I'm simply going to move this line from out here, right, to in here. Okay, so now I have a function that's called log prices. I'm going to log it out, the prices, by calling it. So I'm going to comment this line out really quick, line 8, which is console log prices. I'm going to run the function. I want you to think what's going to happen. Okay, so I run it and we get prices. All right, so nothing too scary over there. That seems to work as intended, right? I'm going to comment this back in. And let's take a look at this. Okay, so I'm going to run this. I want you to think what's going to happen now. Okay, so we get a reference error, as I mentioned in the demo earlier, right? We have a reference error, prices is not defined. So what does this mean? That means, technically speaking, that prices, when JavaScript comes down here, and notice that this is happening for me specifically on line number 8, which is this line right here. This prices is actually being logged out first, as you can see right here. We are getting this logged out. However, when we try to refer to prices down here, something is breaking. So this reference error means that when we are trying to access this variable named prices, JavaScript cannot find it. It just doesn't seem to exist. Okay, so that's kind of strange, right? Because we have prices right here. We just declared it, right? But the only difference was when we moved it inside of the function. Okay, so this is a scope issue, right? When we are declaring variables with let or const, right? And they are inside these curly brackets, those variables cease to exist. They disappear after the last curly bracket. Okay, so in this case, prices only exists between these curly brackets. We cannot access prices outside of here, which is why when we try to log it out in here, inside the curly brackets, it's okay. But when we try to log it out here, it is not okay. We get this reference error, prices is not defined, because it doesn't exist at this point, right? Technically, the way you can think about this is prices is actually created right here when we call the function. Then it's logged out and then it's destroyed. It disappears. Okay, it literally gets erased from memory eventually, right? So we actually can't access it over here. Okay, if you think about why this is, there's a lot of efficiency reasons for this. If we just kept around all the variables everywhere for all of our programs all the time, we would eventually run out of memory very quickly, right? Because we would probably not, like, what's the point of keeping this around? We can just create it every single time the function is called, right? So if we recall this function 100 times, we're going to create prices 100 times. We're not going to stick it around and then refer to it 100 times. Okay, so without getting too deep into that, let's kind of keep going with these concepts. So hopefully this makes sense. Now, let's look at another example. I'm going to walk through the one on the left and we'll go through the one on the right real quick as we start to kind of escalate the complexity of this topic. So here we have prices, right? And it's going to point to an array, just like before. We have log prices. It's going to log out the prices as a function, okay? We call log prices and we get the array. But we can also console log prices because it is declared out here, right? It is not inside the actual log prices function, which means that technically it's like it lives long enough to kind of be logged out over here as well. So that's what we saw in our first example. Now let's take this and kind of make it a bit more complicated. And now we're starting to get into like closure land very closely, almost, right? So let's imagine I take this code right here, okay, that I have highlighted on the left, and I literally copy and paste it, right, into a function, right? So I'm going to create a wrapper function, and I'm going to copy and paste all the code on the left inside of that wrapper function, right? Now, if you think about how this function works, let's ignore the console log down here, just this function. If we are inside this function, all of this code should work the same as it worked outside the function, right? We have prices, we have a function. This is a little bit strange, right? Because we're defining a function inside of a function, but it's like, okay, yeah, I guess that kind of makes sense, right? Because it's just a variable and we can assign anything to the variable. In this case, we're assigning a function to the variable. So that's fine, great. A little bit wonky, but we'll kind of go with it. So assume we can do that. And then we call the function, which was declared right here. So that's fine. And we get the prices logged out. And we can also log prices out here, right? So literally this code is going to work inside of a function as well. Okay. But now if we try to log prices out here, we are going to get the same issue. We're going to get a reference error, right? Because if we go with the rule that I mentioned earlier, right? The curly brackets define the scope or where this variable lives. Prices is going to start here and it's going to end here. We're not going to be able to access it past this curly bracket, right? Which includes this area down here. So we're going to get a reference error again. It's going to be not defined. So just to cement that a little bit, what I'm going to do is I'm going to take this and I'm going to wrap it in a const wrapper function. Okay. And I'm going to take all of that and let me just double check what I had in there. Console log prices was down there. And I'm going to kind of put it inside of this function. Okay. And I'm going to take prices. I'm just going to move it back out here, just like that. Okay. So I have prices inside the wrapper function. I have log prices, which is going to log out the prices. I have log prices being called and then console log prices. I'm going to log out, or not log out, comment out this last line 10 in my case. Clear out my console here. I'm going to do sorry, not console log. I want to call my wrapper function. Now, there is a lot happening here, but it's nothing that we haven't seen before. I would like you to think, what are we going to see when I run this code? Okay, so I'm going to run node. And I'm going to run intro.js, and then we get our array printed out, right? So why is that happening? Well, we're calling the function. We're going to come in here. We're going to create this array and assign it to prices. We're going to create a function and assign it to log prices, which is logging out prices. And then we are going to call that function, and it's going to come up here and run this code, and it's going to log prices, which is up here. So a little bit weird, right? Because like, well, you know, if this was in here, would this run the same way? Let's try this. I'm going to run this and it does, right? Because prices exist between here and here. So that's fine. So it seems to be the case that if prices exists kind of in between here and here, right? Or between here and here, it's okay. We're good. We can kind of use it here, right? But we can't do this. And actually, before I do, I'm getting ahead of myself here. Just to really show you that prices does exist, right? I'm going to comment this back in, and I'm going to run this, and you can see that we do get prices logged out, right? This is happening from the log prices right here, the first one. The second one is happening from inside the wrapper function itself. So prices seems to exist both in this scope and inside the log prices scope. Okay. However, if I try to log it out here, hopefully now you can see, right? This is going to give us an error. So if I run this, I'm going to get that same reference error, prices is not defined on my line 15, because it only lives in between these brackets. It doesn't live outside over here. Okay, so let's keep going with this. Now, this is really what I mean when we're talking about closures. Okay, so this all kind of ramped up to this moment. Let's see how we can explain this the best I can. So I took that function, wrapper function. It has prices inside of it. It has log prices inside of it, which logs out prices. And then we're calling the log prices function. I got rid of that last console log because we don't really need it for this example. Okay, so this code does work, right? We saw that it works, right? So if I kind of get rid of this and I get rid of this, and I run this, we know that this code works just fine, right? So let's modify this slightly. If we look at the code between the left-hand side and the right-hand side, just this part right here, right? The only difference, right, if you look closely, is the last line, okay? Instead of calling the function inside of the wrapper function, I'm going to actually return the function, okay? Now, this is where your mind probably is being like, oh my goodness, what is happening, right? I remember when I first looked at this, my mind pretty much exploded at this moment, right? I was like, returning a function, what does that even mean, right? Like, how is that possible? What is the use of this? When would I, like, does that even work, right? So it turns out in JavaScript and in many other languages, but not all languages, functions are what are called first-class citizens, I guess, right, of the language. We can move them around, we can pass them around, we can treat them just like any other type, just like numbers, just like strings, arrays, etc. Functions can be passed around, moved around, returned, and all sorts of other things, just like those other types. So since we created a variable here, of course we can return that variable because we've been returning variables up until now dozens and dozens of times, right? So now, here is the interesting part. If I'm returning this function and I was to ask you, how do we call a function? We know that we call a function with parentheses. right? But this is where things get a little bit tricky. If I do this down here, const log prices is equal to wrapper function. I want you to think about what this line is doing. This is really central to understanding how Clojure works. What we're saying here on this line is please go and call the wrapper function, right? It's JavaScript, so we have to say please, otherwise it won't do it, right? So JavaScript's going to run off and it's going to be like, okay, I know where wrapper function is. I'm going to come over here. It's going to execute all the code inside here, including the return statement. Well, what is this return statement? We are returning a function. Okay, well, which function are we returning? We are returning this function right here. Okay, well, what does this function do? This function console logs prices out. Okay, that seems easy enough. So we're returning a function, which we can call, and its sole job is to log out prices. Well, where's prices? Prices is right here, right? We know that we can call log prices like this and it seems to work, right? So now the question is, if we get back the function, right? So we're getting back this function, but we haven't called it yet. That's the key. We're just getting back the function object itself, right? This is just function log prices. We're not calling it. To call function, we need the brackets after it, right? So if we call it, just like we did on the last line of the left-hand side, miraculously, we actually get the prices logged out. We do not get a reference error, okay? I'm going to repeat that one more time because this really is what Clojure is. We are getting back a function from calling this function. This function has access to prices inside of it. If I call that function, it's going to give us the expected output, even though technically prices itself doesn't exist out here. Prices only exist in this scope, but because of Clojure, this function has access to this scope because that's where it was created. Okay, so this is a bit confusing. So let me kind of give a colored demo of what's happening here before we actually code this out ourselves. So this is what the scopes actually look like. Okay, I wish I could like frame this. I love the colors here. I noticed that I actually kind of messed up some of these colors because I guess purple and pink don't really go together. But I hope you understand this. Yeah, it's I like these colors. So what we have is a global scope. Every single program has what's called a global scope. Even when we work outside of Node.js, inside of the browser, using technologies like the DOM and React and things like that, there is also a global scope over there. It's just slightly different, but it's still a global scope. Global naturally just means everything, right? Everyone and everything, right? So if we think about our program, everything is running inside of global scope. As soon as we create a function like this, so in this case, wrapper function, right? We are creating its own scope. We can create scope in other ways, but since we're talking about Clojure, we're going to focus on functions, okay? This wrapper function scope is this yellow area right here. Everything in between the curly brackets. All right. So prices and then log prices and return log prices is all inside the wrapper functions scope. All right. Now inside of here, the wrapper function, we're also creating another scope, right? We're nesting these scopes inside of each other. We're creating a function called log prices, which only does one thing, but it's still creating its own scope. Okay. This is the pink one right here. So what we have in this program is three scopes. We have the global scope, which is the outer scope. We have the wrapper function scope, which is solely responsible for everything inside wrapper function. And we have the log prices scope, which is the smallest scope in this set, which is only able to see and responsible for things inside log prices. Okay, so once we've done this, what we can do is down here in the global scope, well, we can ask JavaScript to go and find wrapper function and actually call the function. That's what these parentheses are after wrapper function, right? And we can do that because wrapper function is right here. It exists technically, this variable exists inside the global scope. Okay, so if we call it, well, we get back this log prices, which is also a function, right? And that's what we have here in green. And if we call log prices, then we're going to be calling this function. And we're calling this function inside the scope that it was made in. Okay, so in this case, we're calling log prices in the context of it knowing about prices. Okay, because prices is right here. So what does this really mean? Okay, I noticed that without actually diagramming this out, it becomes ultra confusing. So this is what it means when we are looking for prices. So I want you to think of the case where right here we're calling the log prices function, which is calling this function. What code are we going to execute? We're going to execute this console log right here. This console log is telling JavaScript, hey, please go and grab the prices variable and whatever it points to, and then log it out to the screen. Okay, so we need to find prices and whatever it is pointing to. Okay, that's what this line is doing. So what does that look like? Well, we end up with something like this. JavaScript says, hey, is there prices in this scope for log prices? Right? No, there isn't, right? There is no const prices or let prices inside of here. So what does it do? It looks one scope up. JavaScript will always check one scope up and up and up as it goes until it hits the global scope for variables that it cannot find in the current scope. Okay, so if we don't see this variable inside prices in log prices, then we're going to look in the wrapper function, and then we would find it there. So we use that variable. Okay, this is what closure means, because this function here, this inner function log prices, technically has access to this prices out here, even though it's kind of its own separate function, because it's nested inside the scope of wrapper function. Okay, so the next question you might ask is, well, what happens if it wasn't there, right? What if JavaScript didn't find prices inside of wrapper function? Well, that's what we'd have over here, right? We would walk through this again. So let's start at the beginning, just so this makes more sense, because repeating this really does help. Log prices is going to ask the console log prices. It's going to ask, hey, do I see prices inside of the log prices scope? No, there is no log prices in here. Okay, don't worry yet. We have a few other scopes to look through. Maybe it exists in some other scope above me, right? So it's going to look in wrapper function, and JavaScript is going to be like, hey, is there prices inside of wrapper function? Well, no, there is no prices here. Well, we still don't have to worry. We're sweating a little bit at this point, right? But we don't have to worry fully yet, because we still have one more chance. It might actually exist in a scope above us. So we're going to check the global scope next. Okay, and in this case, we do thankfully find prices inside the global scope, and we can actually log it out here inside of log prices, even though it doesn't exist in that scope or even in this scope. It's going to find it in some scope that is above us, in this case, the global scope. So you can think of JavaScript as literally hopping up these scopes, hunting for these variable names if it doesn't find it in the local scope. Now, the next question you might ask is, okay, that's wonderful. What happens if it's not in the global scope? Well, in that case, we would get the reference error again, because it's not found at all. And in that case, it just doesn't exist. So let's take a look at some of these before I look at an analogy with you. So we're going to look at closure.js. So I'm going to just copy over, where's my prices? My prices variable here. We're going to do this from scratch. Okay, so we have prices over here. We're going to create const wrapper function. This is going to be a function. Okay, and inside this function, if we're going to simulate kind of this setup right here, actually, I should probably say this setup right here, I'm actually going to move prices inside of wrapper function. I'm going to create another log prices function inside here. And this is going to simply console.log out prices, right? And just for sake of completeness, what we'll do is we'll call this log prices function inside wrapper function. I'm going to call my wrapper function, and we're going to make sure that this works. And it does, right? So that was our previous example. We don't want to call it here though. We want to be able to delay when we call it. Okay, so instead we're just going to return this function. Okay, I'm going to say const, and I'm going to show you we can actually name this whatever we want, right? For example, I can even just name this like result if I want to, right? If I console.log out the result, this is tricky. I'd like you to think before I run this, what are we going to get logged out? All right, here we go. So we're seeing that result is actually pointing to the function log prices. Okay, this is super important. Where is this function? It is right here between lines 4 and 6 in my case. This is literally the function that result is pointing to on line 11. Okay, so if we have this function, I want you to think, if we have log prices, well, how do we call it, right? Well, we just did that. I erased it, right? We would call it like this, right? That's how you call a function. If I know that this is a function, I can call it by using parentheses, right? So let's see what happens. I'm going to get the same thing, function log prices, but now I'm actually going to get my prices logged out, and that's coming from line 4. So let's trace this really quick. I'm declaring a function. Right? Let's pretend that's all we see. We have a function. Okay, it's called wrapper function. Then I'm saying create a variable called result and point it to the return value of calling wrapper function. So JavaScript is going to go say, okay, let's go find wrapper function and let's call it. So we're going to open this up. We're going to create a variable called prices, which is this array. We're going to create a variable called log prices, which is going to log out prices. And then we're going to return that function log prices. Right? So result is going to be the function log prices, which is what we see when we log it out. Now we know what a function that we can call. We can call a function using parentheses. So if we put parentheses after a result in this case, we're going to execute the function that was returned, which is which function? It's log function or log prices, which is this one right here. So we're literally going to go from line 14 to line 4 in my case and execute this function code. We're going to console log prices. JavaScript is going to say, hey, does prices exist in this scope, right? Is there prices over here? Well, there isn't, right? We don't see it over here. So Java's going to say, okay, don't worry. I'm going to check the scope above me. I'm going to look upwards one scope. And that scope above log prices is wrapper function. It's going to say, hey, do we find prices out here, right? Is prices out over here? Well, it is, right? We see it right here, which is why we get it logged out over here. I'm going to show you that if I move this in here, I'm actually going to get it logged out as well. Okay. Now here's a brain teaser for you. To really test your understanding with this, I'm going to copy prices. I'm going to copy that line and I'm going to put it up here. I'm going to change up these prices. In fact, maybe I'll just put one price in here. I'll say a price of 100. Okay. I want you to think, when I run this code, what is going to happen? This is a tricky one. All right, let's see. So I'm going to run this and I'm going to get prices logged out. There's no error, but it's going to be this prices on line 6. All right, so why is that? Let's trace this again. So hopefully up until here, we've understood, right? Result is going to be which function? It's going to be log prices. I keep saying log function, log prices, right? We're going to execute log prices. So we're going to come here, line 5, we're going to execute this code. We're going to create a variable called prices. And then we're going to log out prices. JavaScript is going to say, hey, does prices exist in log prices? Yes, it does. It's right here. We literally just created it. So we're going to log that out, right? If it didn't exist, if I comment it out, what do you think would happen now? We'll run this one more time and you'll see that now we're getting the prices out here, right? Because when we do that step of looking for prices here, it doesn't exist. So we're going to look a scope above us. And it does exist out here inside wrapper function. Okay, so now to really push this, I'm going to create const prices out here, and I'll just put, one price in here, 1337. Why not? Right? So now if I run this code, I want you to think, which prices are we going to get? Run this, we get 100. Okay, so hopefully that makes sense. Nothing really changed there between kind of this version and the version where we had it in scope over here. JavaScript finds it in this scope, so it's going to use that. It's not going to keep hunting up the scopes. But now if I comment this out, hopefully you can imagine what happens if I do this and I try to run this code. We will finally get the prices in the global scope being logged out. Okay, so out here we are in the global scope. Okay, this is the wrapper function scope, and then this is the log prices scope. Now, just to show you what happens if I didn't have it in the global scope either, so it's not in the log prices scope, not in the wrapper function scope, and not in the global scope, and I run this code, you can see that we indeed get a prices is not defined. This is a reference error because it's just not found in any scope. All right. Now, one crucial bit of information here. We cannot access scopes that are inward. We can't reach into scopes to access variables. Variables can only be checked upwards, up through the scopes. So if prices is being looked for here, we're first going to look over here. This is going to be our first check. Then we're going to look over here. This is going to be our second check. And then we're finally going to look up here. I should say 3, right? So this is the order of prices being checked for, right? We're going to look at log prices, wrapper function, and then global scope. Now, what we can't do, as you can probably imagine, is imagine if I have prices only inside of log prices, right? I have prices defined. So if I run this code, it's going to work, right? It's going to log out prices, which exists inside of log prices. Now, if I try to log out prices out here, prices, hopefully you can see that this is not going to work, right? Because JavaScript is going to look for prices in this scope, or a scope above it, but we're already in the global scope. So JavaScript is going to basically see all of this and be like, does prices exist? Well, no, it doesn't. So if I run this, we're going to get a reference error. Prices is not defined. Right? If I commented out this variable right here, which makes it defined in the global scope, then we would actually get that variable logged out, right? And similarly, if prices existed in here, right, we still wouldn't be able to access it from the global scope because we can't reach into other scopes. We can only look upwards through the scopes. Okay, so if I ran this, we would also get a reference error, prices is not defined, because it exists inside wrapper function, it exists inside log prices, but it does not exist out here in the global scope, which is where we're asking for it. So hopefully I've hammered that point home hard enough. This is definitely quite tricky, but hopefully when you see it in this way, it makes a bit of sense. To wrap this up, I'd really like to show you an analogy because I think that this really helps kind of give it a bit more of a visual, as apart from just staring at all these codes and boxes and lines going everywhere. So the most important rule, really quick, before I show you this analogy, is that the golden rule for closures and scope is this single line right here. We can only see things in our own scope as well as any scope above us. So we can look up scopes. The reverse is not true. We can't look into scopes. Okay, so I'm going to repeat that one more time because this is what closure is. We can only look at variables or state within our own scope or any scope that's above us. Now for the analogy that I promised you, I would like you to pretend that we have a room very similar to those rooms that you might see in like those cop TV shows or detective TV shows, for example, where normally you have someone sitting on the inside and they look really sad and upset and they're going to get interrogated, for example, for doing something wrong. Hopefully they didn't do it. And the detectives are outside kind of mumbling and giggling amongst themselves, trying to figure out what's happening with this person. So I want you to imagine that setup. Usually in that setup, they have those kind of mirrors that are like the one-way mirrors, like the privacy style screens, right? Where the detectives are able to look in to the person in the room, but the person in the room only kind of sees a mirror or doesn't really see anything at all. But we're going to flip that around. Okay, we're going to make it so it's facing the other way. So the people outside can't see in, but the people inside can see out, right? So just for this analogy, just imagine we flip it around. So I'd like you to imagine that we are kind of the detectives, right, in the outer room. And this is us right here, right? We are this person right here. And imagine that we have like a chalkboard. Okay, so we can write messages on this chalkboard. We also can see that there is this kind of glazed or like glassy mirror on the wall. And we know that there is a room inside there and there might be someone in there that can see us, but we can't see anything inside this room. It's basically a black box. But this blackboard or chalkboard is positioned in such a way that people inside of this room can actually see it because it's positioned right outside this window. Okay, so we can't see in the room, but they can see outside, and we can write on this room to send messages into the room. Okay, so that's the analogy that we're going to go for. So we're currently in room number 1, and we can not see anything in room 2, but we know there's a room 2 over there. And in theory, room 2 can see this. So if we go into that room 2, this is what it looks like from room 2's perspective. So this is the person inside the room. Okay, so here's a person inside the room. This is us. We were standing over here with our chalkboard and we wrote hi as a variable inside there. The person in the room can see through the screen and see what we wrote as a message on this chalkboard. Okay. Now, if you imagine this setup expanded to multiple rooms, this is kind of what it would look like. Right? If we had a third room, for example, you can imagine the person in the third room can see into the second room as well as the first room because they can see through all of the screens. And the person in the second room can see everything in the first room, but not in the last third room. Right? So if we think about this from the perspective of this final room, you can imagine that they can basically see both of these chalkboards. Right? So they can see both the messages from a room, the first room, as well as this room over here for room number 2. Okay, so it's a bit hard to draw out since I don't really have a 3-dimensional view of this, but hopefully that kind of makes sense. So the key here is basically that the outer scopes, which are defined by these rooms, can't see into the rooms. We can't reach into other scopes. So if this global is a room, global cannot see inside here. It says privacy screen protected. Okay, all the variables and stuff that's declared in here are secret. They're hidden from the global scope. And that's true for all scopes. Okay, if I open up my wrapper function and I look at this function, the same thing is true for that. Wrapper function cannot access anything inside of here. Okay, if I create variables in here, they are kind of secluded out to just this function. Okay. However, what's interesting about closures is that if I were to, for example, do this example right here, not sure why that moved my screen over. A variable, since it can look through those windows, up through the scopes, right? So now we're looking at the reverse. We can't look down scopes, but we can look up scopes. We can actually access and we remember what variables were in the scopes above it. So even though I'm calling result down here, and I'll get rid of this log, right? And I run this code, we'll see that we actually get this 100, even though that is in the wrapper function scope. Since it's in a scope above log prices, it's kind of saved, or there's a state or memory that that log prices can remember or have access to because it's in an upper scope. Okay. Now, this is a very, very tricky topic to wrap your head around. It definitely takes a lot of time and practice. You might even be looking at this and being like, that's great. That even kind of makes sense. But when would we ever use this? Right? Like, is this just like purely pedantic? Is this only like when you're studying this stuff and then it's kind of pointless after and just for interest? Absolutely not. Right? In fact, a lot of tools that we use day to day solely rely on this concept if you really break it down and peel them apart behind the scenes. The key here is that we can stash stuff here away in this kind of, in this region, right? In these scopes, and other scopes can't have access to them unless we provide access to those functions. Now that might seem confusing, but But we are going to work through a bunch of exercises in the next video together to actually see how this can be used in practice with some really interesting practical examples that use Clojure to really hammer this point home. But the main thing for this video is to understand the concept and the mechanics of Clojure so that when we actually put it into practice, we can predict whether something is going to be in the scope or in the memory or not, depending on where it's located. So I hope this video was interesting and valuable for you. If it was, I'd love it if you could like the video and subscribe to the channel. I'd love to also hear in the comments, have you heard of this concept before? Have you seen it in other languages and tried to implement it? What experience have you had before with Clojure? Or have you seen it defined differently in different places? And can you think of seeing this anywhere, even in JavaScript, in the wild, like in different frameworks, for example, hint, that you might be using? Right? In the next video, as I mentioned, we're going to go through a bunch of practical examples using this concept of Clojure and really hammer home the kind of important points as to where in practice, in the real world, where it can actually be used. I have some tricky ones in there that are super exciting. I can't wait to get to that video. I'll see you there.